Good morning, students. In last class, we studied how to solve some examples on polar form, right? What is our polar form? All of you know that. What is our polar form? Polar form of a complex number z is equal to r into cos theta plus I sin theta. Then what is r? R is modulus of a complex number. So how we find r? R is equal to square root of x square plus y square, right? For finding theta, which form we have to use here? Tan theta is equal to modulus of y by x, right? By using this form, we can find angle. After finding angle, next what we have to write? Argument of complex number, right? For writing argument of complex number, we have to check given complex number exists in which quadrant, right? Once again, I will say that one, right? Okay. X, X dash, Y, Y dash, right? In first quadrant, X is positive, Y is also positive. If X and Y both are positive, then argument of Z is equal to theta, right? In second quadrant, x is negative, y is positive. X is negative, y is positive. Argument of z is equal to pi minus theta. Whereas in third quadrant, x is also negative, y is also negative. Therefore, argument of z is equal to theta minus pi. Okay. In fourth quadrant, x is positive, y is negative. Therefore, argument of z is equal to minus theta. Is it right? Argument of z is equal to minus theta. Suppose a given complex number is, these four are the quadrants, right? Before writing argument of z, we have to check that complex number exists in which quadrant, right? Here we have to remember one thing. Suppose a given complex number is like this: minus a plus I 0. Suppose a given complex number z is equal to minus a plus I 0. Real axis is minus, imaginary axis is 0. If real axis is negative, means that exists negative side of x-axis, right? Already I said x-axis is nothing but real axis. Y-axis is nothing but imaginary axis, right? Z is equal to minus A. Minus A means it exists here, right? Therefore, angle exists here. This is our angle theta, right? 0 to 180 degree. Then what is here? Theta, how we write argument of Z for this? Argument of Z is equal to pi. Angle of this one is pi, right? Because already x value they mentioned minus. Real is there only. That's why argument of Z is equal to pi, we can say, right? Suppose if they give Z is equal to 0 plus I into B. Z is equal to 0 plus I into B. Only imaginary axis is there, right? Only imaginary axis is there, real axis 0. If imaginary axis is there, then imaginary axis value is positive, means that argument of Z or angle exists here. Angle exists here means how we write theta is equal to pi by 2. If negative side is there, means z is equal to 0 minus I. B is there, means angle how we write, negative side means negative, theta is moving with clockwise direction. If theta is moving with clockwise direction, means theta is equal to pi by 2. We have to remember these two things, okay? If the given complex number exists on x-axis, means exist on x-axis, positive side of x-axis angle is 0, negative side of x-axis pi, right? Positive side of y-axis pi by 2, negative side of y-axis minus pi. Is it clear? Okay. In last class we completed fourth example. Next one, fifth one. Fifth example is minus 1 minus I. Fifth example, minus 1 minus I. Solution. Given complex number z is equal to minus 1 minus I, right? Comparing this complex number with z is equal to x plus iy. Comparing z is equal to x plus iy, whereas x is equal to minus 1, y is equal to minus 1. X value is also minus 1, y value is also minus 1. This one we can also write, this one we can also write. Z is equal to, first we will solve, after that we will discuss. Or z is equal to minus 1 plus of minus 1 into I, right? Minus 1 plus of minus 1 into I. Plus into minus, minus only, right? Therefore, x is equal to minus 1, y is equal to minus 1. Then how we find modulus? Modulus of z or r is equal to, what is our form? X square plus y square. Then which is equal to, square root of x square is minus 1 whole square plus minus 1 whole square. Then which is equal to, power is even, right? That's why minus becomes plus. 1 plus 1. Therefore, r is equal to root 2. What is our modulus? Modulus of r is equal to, we got root 2. Next, what we have to find? Next, we have to find theta, right? Therefore, tan theta is equal to modulus of y by x. Then tan theta is equal to modulus of, what is y here? Y is equal to minus 1 divided by minus 1. Then tan theta is equal to, inside the modulus value become plus, right? 1 by 1 is nothing but 1 only. In which angle tan value is 1? We know that tan 45 degree is equal to 1 value, right? Tan pi by 4. That's why, which implies that theta is equal to, what is our value? Theta value is pi by 4, right? After getting theta, we have to find argument of z, right? Since real and imaginary exist in x third quadrant, right? In third quadrant. Therefore, argument of z is equal to, in third quadrant how we write? Theta minus pi. Therefore, argument of z is equal to theta value. Theta is equal to pi by 4 minus pi, or which is equal to 4 is our LCM term. Then pi minus pi 4 pi, which is equal to, or argument of z is equal to minus 3 pi by 4. Okay, then what is our polar form? Polar form of a complex number z, that is x plus iy is equal to r into cos theta plus I sin theta, right? Whereas the polar form of what is our given complex number? Given complex number is minus 1 minus I is equal to, what is r? R is equal to root 2 into cos of polar form of minus 1 minus I is equal to, polar form of this complex number is equal to, r is there. In place of r, we have to write our r value. What is our r value? R value is root 2. Then cos theta, theta is equal to, theta should be principal value, right? Theta should be principal value. Principal value of theta, theta principal value is minus 3 pi by 4 plus I sine minus 3 pi by 4. Another one step also we can write, right? Which is equal to, we can answer this one as root 2 into cos of minus theta. Cos of minus theta is cos theta, right? Cos of minus theta, cos theta. Sine of minus theta, minus sine theta. That's why sine of 3 pi by 4. Closing. Okay, because cos of minus theta is equal to cos theta. Sine of minus theta is equal to minus sine theta. Already we studied this one in trigonometric functions. Is it clear? Okay. Here given complex number is minus 1 minus I. This is our complex number. We are comparing this complex number with x plus iy. X value is minus 1, y value is minus 1, right? Here we have to find modulus. Modulus form is this one, right? Next, r is equal to, we got root 2. Then for finding theta value, we are using tan theta. Y by x, right? Y value is negative, x is also negative. Inside the modulus, negative values becomes positive, right? Tan theta is equal to 1. In which angle tan value is 1? Tan 45 degree. 45 degree we are writing in radian form, right? Radian form we can write pi by 4. Tan pi by 4 is equal to 1. That therefore which implies that theta is equal to what is our value theta? Theta is pi by 4. Here first we have to, after getting the value of theta, we have to check these to exist in which quadrant, right? X is negative, y is negative means the given complex number exists in third quadrant. In third quadrant, how we write argument of z? Argument of z theta minus pi, right? Already we know the value of theta. What is our theta value? Pi by 4. Pi by 4 minus theta minus pi. 4 is our LCM. The numerator pi minus 4 pi. Pi minus 4 pi is equal to minus 3 pi. Minus value is greater than plus value. That's why minus 3 pi by 4. This is our argument of z. Right? General form of a general complex number polar form is this one, right? That is r cos theta plus I sin theta. Given complex number is minus 1 minus I. Polar form of this complex number is, here we wrote modulus, next cos of theta. Theta value is minus 3 pi by 4 plus I sin 3 pi by 4. Minus is there, right? We know cos of minus theta is cos theta. Sin of minus theta is minus sin theta. This one we studied in trigonometric functions. Okay. Next one. Okay. Next, sixth question. Question number 6 is minus 3. Sixth problem is minus 3. Okay. Given complex number is minus 3. How we write? Z is equal to minus 3. Real term is there, imaginary term is not there, means how we write? Plus I into 0. 0 into anything is 0 only, right? Therefore, comparing with our general complex number, what is our general complex, general form of complex number? Z is equal to x plus iy, right? Here x is equal to minus 3, y is equal to 0, right? Next we find r. R is equal to square root of. We know that for finding modulus, what is our form? X square plus y square, which is equal to square root of minus 3 whole square. We know y square. Y value is 0, right? Therefore 0 square. No need to write it square, right? Which is equal to power is 2, minus becomes plus, square root of 9. 9 plus 0 is 9 only. Then root 9 value is 3. Therefore r is equal to 3. R equal to 3. Next we have to find the value of theta, right? That is tan theta is equal to modulus of y by x. Then tan theta is equal to modulus of what is y? Y is 0. 0 divided by minus 3. 0 by anything is 0 only. Therefore tan theta is equal to 0. Tan theta is equal to tan 0. Tan 0 is 0 only, right? Therefore, which implies that theta is equal to 0. Theta is equal to 0. Angle is 0, right? Here real axis already they mentioned. Real axis is negative. First only I said, right? If real axis is negative means argument exists in second quadrant, right? Argument exists in second quadrant. Therefore, first we write here. Since real axis is negative, okay. Real axis is negative. Therefore, given complex number exist in second quadrant, right? Second quadrant. Therefore argument of z is equal to, in second quadrant how we write? Pi minus theta. Then which is equal to pi ki parasities. What is the value of theta? Theta is 0. Therefore argument of z is equal to pi only. Then polar form of complex number is polar form of a complex number that is equal to r cos theta plus I sin theta, right? Or polar form of a given complex number is minus 3. Polar form of minus 3 is equal to what is r? R is 3. 3 into cos of theta. Argument theta should be principal value means here we have to write argument of z or theta value, right? What is our theta? Theta is equal to pi cos theta plus I sin theta. Theta value is pi, right? This is our polar form of minus 3. Minus 3 we can also write minus 3 plus I0. Imaginary term is not there means I into 0 also we can write. Is it clear? Okay. Given complex number minus 3, right? How we wrote minus 3? Minus 3 plus I into 0 because imaginary term is not there. That's why I into 0 we write, right? X is equal to minus 3, y is equal to 0. Here we have to remember one thing. X is negative. X is negative means exist here, right? X dash x. This side positive value of x and this side negative value of x, right? Negative value of x means angle exists here. And if angle exists here means what is theta? Theta is equal to pi, right? That's why r is equal to, first we find r. After writing r, here we find theta value. After finding theta, real axis is negative. That's why argument of z is, if real axis is negative means given complex number exists in second quadrant. Therefore argument of z is pi. Polar form of minus 3 is 3 into cos pi plus I sin pi. Is it clear? Okay. Next. Seventh row. Seventh one is root 3 plus I. Seventh question. Root 3 plus I. Solution. Given complex number z is equal to root 3 plus I. Given complex number z is equal to root 3 plus I. Then what is our x here? X is equal to root 3. Y is equal to 1. Then what is r? R is equal to square root of x square plus y square. Then which is equal to square root of x square is root 3 whole square plus y square is 1, right? Which is equal to 1 square. Then square root get cancels. Here it remains 3 plus 1 square value is 1. Then which is equal to square root of 4. Therefore r is equal to root 4 value is 2. Therefore modulus of z or r is equal to modulus of z or r is equal to root 2. Okay. Then next, for finding theta. Here we are using tan theta is equal to modulus of y by x form, right? Tan theta is equal to modulus of y. Y is 1, right? X is root 3. Then tan theta is equal to 1 by root 3. Tan theta is equal to, in which angle? Tan value is 1 by root 3, tan 30 degree, right? Tan 30 degree, how we write? Tan pi by 6, which implies that theta is equal to pi by 6. This is our value of theta, right? Next, what we have to write? We have to write argument of z, right? Argument of z is nothing but principal value of theta. What is principal value of theta? Principal value of theta is nothing but theta lies in between minus pi to plus pi. That is minus pi is less than. It should be minus pi is less than, theta is less than is equal to plus pi. This is called principal value of theta or principal value of complex number. Then since real and imaginary axis, real axis is x-axis, imaginary axis is y-axis. Since real axis and imaginary axis both are positive. If both are positive means given complex number exists in first quadrant. Since real and imaginary axis exist in first quadrant, real and imaginary axis exist in first quadrant. Therefore argument of z is equal to theta. Then argument of z is equal to, what is the value of theta? Theta is pi by 6. Then polar form of complex number z is equal to r cos theta plus I sin theta. Okay. Or polar form of a given complex number is root 3 plus I is equal to, what is the value of r? R is equal to 2 into cos of theta. Theta should be principal value. What is our principal value of theta? Pi by 6 plus I sin pi by 6. Like this we have to solve. Is it clear? Okay. Next, 8th problem. Eighth question. Question number 8 is I. Eighth question. I nothing but imaginary axis. Real part is not there. Only they gave imaginary part, right? How we write this given complex number? Z is equal to real is 0 plus imaginary is there. We wrote real axis is not there. That's why we wrote 0, right? Here x is equal to 0 and y is equal to 1. Then what is r? R is modulus of z, or r is equal to square root of x square plus y square. Then which is equal to square root of x square is 0 plus y square is 1 square, which is equal to root 1. R is equal to root 1 value is 1. Right? Done. See here. Real axis is 0. Only imaginary axis is there. Right? Imaginary axis is positive, means y is nothing but imaginary axis. X is real axis. Right? Only imaginary axis is there, means we are saying that theta is principal value. Theta is principal value minus pi to plus pi. Right? So here I only imaginary axis is there, means argument of z is pi by 2, 90 degree. Right? Done. Here we will find tan theta is equal to modulus of y by x. Then tan theta is equal to modulus of what is y? Y is 1 divided by x is 0. Tan theta is equal to anything by 0 is not defined, right? That is infinity. Tan theta is equal to, in which angle tan value is infinity? Tan 90 degree, that is tan pi by 2. This implies that theta is equal to pi by 2, right? After finding theta, we have to check given complex number exists in which quadrant. In which quadrant this complex number exists? Both are positive. Both are positive means first quadrant, right? Since real and imaginary axis exist in first quadrant. First quadrant. Therefore, argument of z is equal to theta, or which is equal to, what is the value of theta? Theta is pi by 2, right? Argument of z, or also we can say here principal value of theta. Principal value of theta is equal to pi by 2. Polar form of a given complex number is, polar form of z is equal to r cos theta plus I sin theta. Then given polar form is given Cartesian form is, polar form of given Cartesian is I, right? Polar form of 0 plus I or only I, or I is equal to, what is R? R is 1. 1 into cos pi by 2 plus I sin pi by 2, or which is also equal to cos pi by 2 plus I sin pi by 2. Is it clear? Okay. Next one. This completes your 5.2 exercise. This completes your 5.2 exercise. Right? In 5.2 exercise, last problems are convert each of the complex number given in exercises 3 to 8. We completed 8th problem, right? In polar form. One problem remained. A solved example. We solved example of 7th one, right? 8th one is remained. We will solve 8th question. 8th problem. Already we solved 7th one, right? 8th one is remain. Eighth question is example 8. Solved example 8th one. 7th one we already completed. Okay. Convert the complex number. Convert the complex number minus 16 divided by 1 plus I root 3 minus 16 divided by 1 plus I root 3 into polar form. Convert the complex number minus 16 divided by 1 plus I root 3 into polar form. Okay. Given complex number z is equal to minus 16 divided by 1 plus I root 3, right? Denominator is imaginary term. So what we have to do here? If denominator is imaginary, we have to rationalize this term, right? If we are rationalizing means multiplying and dividing conjugate of this term. Conjugate of denominator is 1 minus I root 3 divided by 1 minus I into root 3. Then which is equal to denominator is in the form of a plus b, a minus b. A plus b, a minus b is equal to a square minus b square. In place of a, what is there? 1. In place of b, I root 3. Therefore, a square minus b square. Numerator, we have to multiply this minus 16 to this bracket, right? Minus 16 as it is, because 1 into 16, minus 16 only. Then minus plus. I keep as it is. 16 into root 3. Or you keep as it is this one. You will cancel. This one is minus 16 into 1 minus I into root 3. Okay, then which is equal to minus 16 into 1 minus I into root 3 divided by denominator 1 square is 1. Square root get cancels. Here it remains minus I square into 3 because square root get cancelled. Or another one step we will write. This is I square into root 3 whole square. Applying square separately. Okay, that which is equal to minus 16 into 1 minus I root 3 divided by 1 I square value is minus 1. We know that I square is equal to minus 1. This minus becomes plus. Or first we write I square value. I square is equal to minus 1. Then this square root get cancels into 3. Then which is equal to minus 16 into 1 minus I root 3 divided by 1 minus into minus plus 3. Okay. Then which is equal to minus 16 as it is into 1 minus I into root 3, right? Divided by denominator terms are 4. 1 plus 3 is nothing but 4. 4 ones are 4 fours are. Then which is equal to multiply this minus 4 inside the bracket. Then it becomes minus 4 plus I 4 into root 3. Right? Our given complex number. What is our given complex number? Given complex number is 4 minus 4 plus I 4 into root 3. For this complex number, we have to write polar form. Right? For For writing polar form, given complex number, we solved already, right? This one we solved already because denominator is I. If denominator is I means we have to rationalize it. After rationalizing, we got complex number. This is our complex number. Comparing this complex number with comparing complex number with z is equal to x plus iy. Then what is our x? X is equal to minus 4 and y is equal to 4 into root 3. Okay, x is minus 4 and y is equal to 4 into root 3. Then here we have to find modulus. Modulus of z or r is equal to square root of minus 4 whole square plus 4 into root 3 whole square. Then which is equal to square root of minus 4 whole square. Minus is there, power is 2. Minus becomes plus. Then 4 square value is 16. Plus here, if you are applying square separately means how it becomes 4 into root 3 whole square is there, which is equal to 4 square into root 3 whole square. Sorry. 4 square into root 3 whole square. This square root get cancels. So here it remain only 4 square into 3. Right? 4 square value is 16. Therefore here which is equal to 4 square value is 16. 16 into 3 which is equal to 48. Right? Therefore 4 square value is 16 into 3. Then which is equal to 16 into 3, 48. 48 plus 16, 64. Therefore, r is equal to square root of 64 value is 8. Okay. Next. Here we know the value of r. Next, what we have to find? We have to find argument value, right? For finding argument, first we have to find theta. That is tan theta is equal to modulus of y by x. Tan theta is equal to modulus of y by x, then which is equal to modulus of, what is the value of y? Y is equal to 4 into root 3, x value is minus 4, divided by minus 4. Here 4 get cancels, right? Inside the modulus, if minus is there means those value becomes plus only. Therefore, tan theta is equal to, here it remain only root 3, right? Which implies that, or tan theta is equal to, in which angle tan value is root 3? We know that tan 60 degree. How we write in radian form? Tan 60 degree is nothing but tan pi by 3. Then which implies that theta is equal to pi by 3. Which implies that theta is equal to pi by 3. If theta is equal to pi by 3, next what we have to write? We have to write argument value, right? See here, x is negative, y is positive, right? So real axis existing, real axis is negative, imaginary axis is positive. Real is negative, imaginary axis is positive means given complex number exists in, this complex number exists in second quadrant. In second quadrant, x is negative, y is positive, right? Since real axis is negative and imaginary axis positive, given complex number exists in second quadrant. Okay, given complex number exists in second quadrant. Therefore, argument of z is equal to, in second quadrant how we write? Pi minus theta, which is equal to pi minus, what is the value of theta? Theta is pi by 3. Therefore, pi minus Theta is pi by 3. Then argument of z. Argument of z is equal to 3 is our LCM term. Then 3 pi minus pi is equal to 2 pi by 3. Okay, 2 pi by 3. Therefore, polar form of a given complex number is polar form of a given complex number is polar form of a given complex number is minus 4 plus I4 root 3 is equal to, what is R? First we write polar form. Okay, polar form of complex number Z. General form we will write. Z is equal to R cos theta plus I sin theta, or polar form of complex number minus 4 plus I4 into root 3 is equal to, what is R? R is 8. Then cos theta, argument of theta 2 pi by 3 plus I sin 2 pi by 3. This is our polar form of a given complex number. Okay. What is our given complex number? Given complex number z is equal to minus 16 divided by 1 plus I into root 3. This is our given complex number, right? Denominator is imaginary term. If denominator is imaginary means we have to rationalize, right? Therefore, if we are rationalizing term means we have to write conjugate of denominator. If we are writing conjugate of denominator means we have to change the sign of imaginary term. Therefore, we changed the sign of imaginary term. That is minus I into root 3. Multiplying and dividing conjugate of denominator. Then denominator term is in the form of a plus b, a minus b. A plus b, a minus b is equal to a square minus b square, right? So numerator keep as it is. Denominator a square. In place of a, what is there? 1. In place of b, I. Right? Therefore, a square minus b square. This one, here we are applying squares separately. If we are applying squares separately means it becomes I square into root 3 whole square. Okay. Then which is equal to square root get cancels. I square value, already we know I square is equal to minus 1. Therefore, I square value is minus 1. Square into square root get cancelled, which is equal to 3. Minus 1 into 3 is equal to minus 3. See here, numerator keep as it is. Numerator is as it is. Denominator, if we solve this one, we got I square value as minus 1 into 3. Denominator, this minus becomes plus. Therefore, 1 plus 3. Numerator as it is. 1 plus 3 is nothing but 4, right? Minus 16, 1 minus I into root 3. Denominator is 4. 4 ones are 4 fours are, right? Therefore, z is equal to here it remains minus 4. Multiply this minus 4 inside the bracket. 1 into minus 4 is minus 4. This minus becomes plus I 4 into root 3. Okay, this is our complex number, right? Here we have to find the polar form of this complex number, right? Comparing this complex number with this one, right? Therefore, x is equal to minus 4, y is equal to 4 root 3. Then for finding modulus, what we have to use? Square root of x square plus y square form, right? R is equal to which form we have to use? X square plus y square. What is the value of x? X is minus 4 whole square plus y value is 4 into root 3 whole square, right? Minus 4 whole square, minus becomes plus because power is 2. That's why minus becomes plus, then 4 square value is 16 plus. Here apply square separately, then it becomes 2. 4 square into square root of 3 whole square. Square root get cancels, which is equal to 4 square is 16. In here it remains 3. Therefore 16 into 3. Next 16 into 3 is 48, right? 48 plus 16 is 64. Square root of 64 is nothing but 8, right? Then for finding theta value, here we have to use tan theta is equal to modulus of y by x. Y is equal to, what is the value of y? Y is equal to 4 into root 3 divided by x value is minus 4. 4 get cancelled. Denominator is minus. Modulus is there means minus becomes plus only. Therefore, theta is equal to root 3. Then tan theta is equal to, in which angle tan value is root 3? Tan 60 degree. In radian form, how we write 60 degree? 60 degree we can write pi by 3, right? This implies that theta is equal to pi by 3. After writing theta value, next what we have to do? We have to find argument of z, right? Argument of z. For finding argument of z, we have to check the given complex number exists in which quadrant, right? So here real axis is negative, imaginary axis is positive. Real is negative, imaginary is positive means exists in second quadrant. Therefore, argument of z is equal to, in second quadrant, how we write argument of z? Pi minus theta. Theta value is pi by 3. Therefore, argument of z. Here we took 3 as LCM term. Therefore, 2 pi by 3. Then general polar form is r cos theta plus I sin theta. For this complex number, polar form is, in place of r, 8, in place of theta, 2 pi by 3 plus I sin 2 pi by 3. Is it clear? This completes polar form of a complex number. Okay, thank you.
exercise 5.2, 8 problem. That is I. Convert in the form of polar form. So if you write z equal to x plus iy, it is a representation of complex number in Cartesian form. If you write z equal to r into cos theta plus I sin theta, that is representation of complex number in polar form. In terms of using the parameter r and theta, if you convert in terms of that is Cartesian form, if you are converting in terms of r and theta, that representation should be polar form. So let us write this in the form first Cartesian form, then we will convert in terms of polar form, where radius that is r, not radius, that is modulus r is given by root of x square plus y square, and theta, what is theta? It is called as argument of z, that is given by tan theta is equal to modulus of y by x. So based on this, we are converting a Cartesian form into polar form. So first, let us express that given complex number in the form of Cartesian form. Z equal to it is I. So writing this one in the form of x plus iy. There is no real part, means real part is what? 0. 0 plus x plus I into y. So in place of x it is 0, in place of y it is what? 1. So this is of the form x plus iy. So writing a complex number in the form Cartesian form, that is x plus iy. Real part is 0 and imaginary part is what? 1. So comparing this complex number in the form of x plus iy, here x equal to 0 and y equal to 1. So we know that is to convert to the form polar form, z equal to r into cos plus I sin theta, where r, that is modulus of z, is given by root of x square plus y square. Root of x square plus y square. Root of x is what? Here 0, so 0 square, and y is what? 1 square. 0 square is what? 0, 0 plus 1. 0 plus 1 is what? 1. Root 1 is equal to what? 1 everything. That is modulus of z, that is r is equal to what? 1 everything. Next, let us find the theta, that is argument of z. To find the theta value, we are using tan theta. Tan theta equal to what? Modulus of y by x. Since in the right angle triangle, if you take any point p of x from y, so this is your y distance and this is your x. So we know the distance of y and x, so we are calculating ratio of opposite by base, that is tan theta. For that is I am taking tan theta is equal to modulus of y by x. So tan theta is equal to, so first we'll find the theta base considering both x and y as positive only, that is modulus it gives a positive quantity. What is y? It is 1. And what is x? 0. 1 by 0 it is. What is 1 by 0? It is what? Infinity. That's right. So modulus of infinity again it is a infinity. So for which angle? Tan is infinity, that you have to check. Tan 45 is what? 1, tan 60 is root 3, tan 90 is equal to infinity. So this infinity we can write as what? Tan of 90. That is pi by 2. So which implies, so tan theta equal to tan pi by 2 implies theta equal to pi by 2. You can write, implies theta is equal to pi by 2. So why we take modulus? Because suppose if you take one point here, that is 1 plus I, it comes in first quadrant, and one more point if you take minus 1 minus I, it comes in third quadrant. If you check for this one, tan theta equal to y by x only. Suppose if you take only y by x, what is y? 1, x also equal to 1. So tan theta is equal to 1 by result 1. For this complex number is what? Tan theta equal to 1 implies theta equal to pi of 4. Similarly, for this complex number, if you are checking tan theta is equal to, what is y here? Minus 1. What is x here? Minus 1. Minus 1 again it is what? 1 only. For this complex number, theta equal to pi over emitting. Again, for this complex number also theta equal to pi over emitting. So, but we know that for a unique complex number only one argument should be there. So for that reason, we are going for that argument as that depend upon the quadrant. If it is in first quadrant, argument as that is equal to theta. If it is second quadrant, argument as that is pi minus theta. If it is in third quadrant, argument as that is what theta minus pi. And if it is fourth quadrant, argument as that is given by minus theta to get different argument for a different complex number. All the distinct complex number has distinct argument to that. So find that one. We are using that rule, that is argument of z depend upon the quadrant. So here x is 0, y is 1. So y is positive, x you can take positive or negative because 0 is either positive or negative. So even any positive take or negative take, the arguments that will be same only. Let us take x as not positive. So we know that in the quadrant, if it is in first quadrant, that is x is positive, y is positive, argument of z is given by theta. Second quadrant, x is negative, y is positive, argument of z is given by pi minus theta. X is negative, y is also negative. Third quadrant, argument of z is given by theta minus pi, and x is positive, y is negative. Fourth quadrant, argument of z is given by minus theta. So you have to find argument as that is theta. X is equal to 0. Let us take x as positive. X is positive, y is positive. X is positive, y is positive. In first quadrant, argument as that is given by theta. Argument as that is given by theta. Since both x is positive, y is also positive, so argument of z, argument as that is given by theta. So argument of z, what is theta we got here? Pi by 2. That is pi by 2. Right? Suppose if I take x as negative, right? X is negative, y is positive. X negative, y is positive means what is the argument that is given by pi minus theta, right? Because 0 is not neither positive nor negative. I am taking as positive. What happens if I take negative? So if x is negative, y is positive. Second part, what is argument that is given by pi minus theta? Suppose if I take x as negative, argument of that is given by pi minus theta. Pi minus what is theta? Pi by 2, right? What is pi minus pi by 2? 180 minus 90, again it is 90 only. So pi by 2 only, pi by 2 only I am getting. So you can take positive or negative because 0 is neither positive nor negative. But preferably we'll take as dot x as positive, y as also positive. That is in first quadrant. Argument that is given by theta. So argument that is equal to pi by 2. So this is what we got, modulus and theta. So polar form of complex number is given by r into cos theta plus I sin theta. Z equal, what is r we got? That is modulus equal to 1 into cos of theta is what, pi by 2 plus I sin theta is also equal to pi by 2. So this is what representing this complex number in the form of a polar form. If you replace, what is cos 90? Cos 90 is equal to what? Cos 90 is what? 0 plus I into sin 90 is equal to what? 1. So 0 plus 1 into is what? It is I only. Again I am getting same thing only. Means representing this Cartesian form in the polar form. That is one of the representation of a complex number, right?
Plus I 0 to what? So 0 is positive. Okay.
One of the student asked the doubt in exercise 5.2, the fifth example. The fifth example is a given z equal to -1 minus I. Convert this complex number z is equal to -1 minus I. Convert it into polar form. Okay. First, compare the given complex number. Compare with given complex number z is equal to x plus iy. Okay, this is called real part of the complex number and this is the imaginary part. Here real part is -1 and imaginary part is also -1. Here x is -1 and y is also -1. Okay, then because we can write this -1 plus -1 into I, correct? We can write this one because plus into minus is again minus. Therefore, x value is -1 and y value is -1. Okay, now find out the modulus, or you can find out the r value, and r value is root of x square plus y square. And what is your x square? That is -1 square. -1 square is 1. And y is -1 square is also 1. Therefore, r equal to root 2. R equal to root 2. After finding the r value, you have to calculate the theta. That is tan theta. What is the formula? Tan theta equal to y by x, and tan theta equal to y value is -1, x value is -1, and this is minus. Again, after cancelling, we get the answer is 1 here because this is modulus now. Therefore, tan theta equal to 1. For what angle? Tan will be 1. Therefore, tan 45. The tan 45 is 1. Therefore, I'll write this 1 as tan 45. Therefore, tan theta equal to tan 45. The 45 can be taken as pi by 4. Because tan pi by 4 value is 1. Okay, and this implies by comparing these two, the theta value is pi by 4. Theta value is pi by 4. Okay. Now check whether this complex number is present in first quadrant, second quadrant, or third quadrant. Here, real part and imaginary part are both are negative. Both are negative. Real part and imaginary part are both are negative. Both are negative means that is in third quadrant. That will be in third quadrant. Because x is also negative, y is also negative. Therefore, it is lies. This complex number is lies in third quadrant. If it is third quadrant, the argument of z is theta minus pi. Theta minus pi. Right. Here, given complex number lie in third quadrant. Therefore, argument of z Okay, this is both are minus here. Argument of z is theta minus pi. And what is our theta here? Theta is pi by 4 minus pi. And what is the LCM here? The LCM is 4. And cross multiplication, this is pi minus 4 pi. And this is minus 3 pi divided by 4. And this is our argument of z. And what is our polar form? Our polar form is polar form of z is r into cos theta plus I into sin theta. And what is this theta? And theta is argument of z. Theta is argument of z here. This theta is argument of z. Therefore, z is equal to, and what is our r value here? Root 2. And this is cos. What is our argument of z? This is minus 3 pi by 4 plus I into sine of argument of z is minus 3 pi by 4. And this is your polar form. And this is your polar.
Many students are asking out whether 0 is positive or negative. How we should take? Suppose if it is z equal to only suppose 1. How to find the amplitude, that is theta. So this 1 can be written as x plus I into y, where y is not 0. So this y you can take positive or you can take negative. In both the way you will get the same answer only. For example, let us find by taking 0 is not positive. So this is in the form of x plus iy, because 0 is neither positive nor negative. If you take in set of integer, what is set of integer? 0, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, up to so on. And positive integer if you take, it is plus 1, plus 2, plus 3, plus 4. And negative integer you take minus 1, minus 2, minus 3, minus 4. Right? So 0 is neither in positive integer nor in negative integer. So 0 is neither positive nor negative you can take. So here also, if you take positive also you get correct answer. If you take negative also you get correct answer only. And how to identify whether this point lies in which quadrant? Depending upon x and y value. That is, x is positive, y is also this positive, it may be negative. For example, if you take z equal to 3 plus I. So this you can write in terms of x plus I into y, where x is 3, that is positive, y also is what? 1, it is positive. It comes in first quadrant depending upon your x and y. So x is positive, y is also positive, it comes in first quadrant. If x is negative, y is positive, that complex number comes in second quadrant. If x is negative, y is also negative, that complex number comes in third quadrant. If x is positive, complex number comes in fourth quadrant. So you have to express that complex number in the form of x plus iy. Depending upon your real part and imaginary part, that decides the in which quadrant the complex number lies, right? So always try to express in the form of x plus iy. So this is your real part and this is your imaginary part. Based on this quantity, we can tell the complex number lies in which quadrant. So let us solve this by taking in both the ways, 0 is positive or 0 is negative also. So I am taking directly, let us find modulus, that is tan theta. Tan theta is equal to modulus of y by x, right? So tan theta is equal to, what is y? So here you can take here x equal to 1 and y equal to 0, right? So x plus iy, x equal to 1, y equal to 0. Y is 0, 0 by x is what? 1. So 0 by any number is equal to what? 0 only. So tan theta is equal to tan of which angle is 0? Tan 0 is equal to 0. So theta equal to what? 0. I can tell, implies theta is equal to what? 0. Now I'll find argument of z. Argument of z depends upon the the sign of x and y. I am taking both x and y as positive only. So x, because there is no meaning that you write plus 0 minus 0. There is nowhere you are writing plus 0 or minus 0. So if I take both, let us assume that both x is also positive, y is also positive. If x is positive, y is positive is in first quadrant. In first quadrant, argument of z is given by theta. Let us consider both x and y are positive. So argument of z is given by theta. That is argument of z is equal to, what is theta? Is 0. When I take both x and y as positive, argument of that is 0. Right? Next, let us take this is, I am taking case 1, both x is also positive, y is also positive. Let us assume that y is negative. Case 2, if I take case 2, x is positive, y is negative. X is positive, y is negative, comes in which quadrant? It is in x is positive, y is negative, it comes in fourth quadrant. If it is in fourth quadrant, or this argument as it is given by minus theta, right? So okay, x is positive, y is negative, I am taking that is 0, I am taking as negative. So argument of z, if it is in fourth quadrant, argument of z is given by minus theta. Argument of z is equal to minus, what is theta? Theta is equal to 0. So theta is what? 0. So plus 0 or minus 0, there is no meaning. Direct will write only 0. So argument of z is equal to what? 0. So in both the cases, we are writing argument of z as what? 0 only. So that indicates you can take any one. It will be correct only. Right? Hope you got this point.